Today, let us explore how process variability impacts yield, a crucial factor in producing reliable and efficient semiconductors. Process variability refers to the fluctuations and inconsistencies that occur during the manufacturing process. These can include changes in temperature, pressure, or chemical concentrations, affecting the quality and yield of semiconductor wafers. For instance, even a 0.1 degrees Celsius variation in temperature can result in a 2% drop in yield due to microcracks forming in the wafer structure. There are several types of process variability: equipment-related, such as inconsistencies in machine performance; material-related, like variations in the purity of raw materials; and human-related, stemming from differences in operator techniques and skills. Process variability can lead to defects and yield loss. A single particle of dust, less than 0.5 microns wide, can cause a chip to fail, significantly reducing the number of usable chips from each wafer. Maintaining strict control over these variables is essential for achieving high yield rates. Manufacturers use advanced monitoring systems, automated controls, and machine learning algorithms to combat process variability. These technologies help detect and correct real-time variations, ensuring a more stable and predictable manufacturing process. Companies implementing these technologies have reported yield improvements of 3 to 5%, translating to millions of dollars in cost savings annually. Let us look at how AI can improve yield by implementing rigorous process control measures. An FAB can reduce variability by leveraging AI and real-time monitoring, increasing yield and saving millions in production costs annually. One critical area where process variability plays a significant role is lithography. This step involves using light to transfer patterns onto the wafer. Even slight variations in exposure or alignment can lead to defects. Advanced lithography equipment, costing upwards of $100 million, and precise process controls are essential to minimize these variations and improve yield. Maintaining a clean environment is also crucial. Tiny particles and contaminants can cause defects during the manufacturing process. Operators in clean suits and stringent cleanroom protocols help reduce contamination and improve yield. For instance, the cleanroom protocols at any fabrication plants help maintain particle levels below 1 per cubic meter, contributing to their high yield rates of over 90%. The future of semiconductor manufacturing lies in further reducing process variability. Innovations in materials, advanced metrology tools, and AI-driven predictive maintenance are paving the way for even higher yields and more efficient production processes. Companies that successfully implement these innovations can expect to see up to 20% improvements over the next decade. Thus, understanding and controlling process variability is vital for the semiconductor industry.